Today we are going over lesson 7.1, solving systems of equations, specifically using substitution. Solving by substitution involves solving for a variable, specifically the one that's usually easiest to solve for in terms of having a coefficient of 1 or even -1, and then plugging it into the other equation. In this case, x minus y is 0, so adding y to each side, we get x equals y. And then plugging that in for y over here, we get 5x minus 3x, and again we're substituting with parentheses, equals 10. 5 minus 3 of x is 2 of x. 2 times what number is 10? X is 5. And we plug 5 right back in here. 5 equals y. So therefore we're going to have 5 as our ordered pair. Again, that stands for the intersection of these two equations. Next, we have negative 5/3 x plus y equals 5. And negative 5x plus 3y equals 6. It's easiest to solve for this plus y up here on top, because all we need to do is plus 5/3 x to both sides of the equation, and we'll be solved with a y equals 5/3 x plus 5. We're then going to plug that in down here for the y, so we will get negative 5x plus, right, we're just still going left to right, 3 times the whole quantity we had up here, 5/3 x plus 5 equals 6. And again, 3 goes into both pieces. So next will be negative 5x plus 3 times 5/3, the 3's cancel, we get 5x, plus 15. Don't forget the 3 goes to both pieces, equals 6. And so now we've got negative 5 plus 5 is 0x. So 15 equals 6 is not true. If you get a statement that is not true, your answer is no solution. Okay. Next, we have x squared plus 4x minus y equals 7, and 2x minus y equals -1. Okay, the bottom one is fairly easy to solve. If we add y to the right and plus 1 to the left, we'll get 2x plus 1 equals y. Okay. Next, we are going to plug in 2x plus 1 for the y value up top. So we get x squared plus 4x minus 2x plus 1 equals 7, because it was a minus y. So that negative is going to go to both pieces. 4x minus 2x will give us 2x. Plus 1 times the -1 is -1. And then we subtracted 7 from both sides, giving us x squared plus 2x minus 1 minus 7 is -8. And we can factor that. We've got some number equals 0. We'll split it up into x plus 4 times x minus 2. If you've got to do a diamond problem to solve that, that's fine. 4 times -2 is -8. 4 minus 2 is 2x. So we've got two different answers here. We got x equals -4 and x equals 2. We're going to actually have two ordered pairs because the top is a quadratic equation. So if you plug in -4, we get 2 times -4 plus 1. -8 plus 1 is -7. So -4, -7 is a point. The next one is going to be 2 times 2 plus 1, again plugging back into the same equation up here, we get 5, and then 2, 5 is our other point. So two answers there. Next, we got x plus y equals 0 with x cubed minus 5x minus y equals 0. In this case, we've got x equals -y on top, and we're going to plug in x where we see the minus y here. So this time we're plugging x in. You could say y equals -x, and we'll have a minus -x, which is plus. But we end up with x cubed minus 5x plus x equals 0. So this time it's a cubic. -5x plus x will be x cubed minus 4x, which will then factor into x times x squared minus 4. And x squared minus 4, perfect squared minus perfect squared, will give us x times x minus 2 times x plus 2. So this all equals 0, and we'll have three different values. We'll have 0, +2, and -2 for x. So we'll have three ordered pairs. X equals -y, so 0 equals -0, 0, 0. 2 equals -y. Gives us -2. So 2, -2, and the same thing will happen with -2. -2, 2 is our other option. So three ordered pairs at work. Next, on to real world problems. A small business invests $16,000 to produce an item that will sell for $5.95 per unit. Each unit can be produced for $3.45. A, write the cost and revenue functions for X units produced and sold. So the cost of X unit is 3.45X plus the amount we had to invest, right? Plus 16,000. That was our total cost. And our revenue is going to be R of X equals 595 per unit, so 5.95X. To find the number of units that need to be sold, we're going to make them equal. So cost of X equals the revenue of X, meaning we put them together. 3.45X plus 16,000 equals 5.95. Subtract the 3.45 from each side, we get 16,000 equals 2.5X. And finishing up, dividing by 2.5 from each side, we get 64,000 units, 6,400 units, pardon me, is where we will break even. 6,400 units. Next, we've got a total of $25,000 that is invested between 6% and 8.5% simple interest funds. The yearly income we want from this $25,000 is at least $2,000. Write a system of equation to represent the investment. So the money we invest is $25,000. So X would be the 6% and Y would be the 8.5%. So the money we invest of X plus Y is $25,000 total. So again, X stands for the amount of money invested at 6%, Y the amount of money invested at 8.5%. So then our combination becomes 0.06X, the interest earned from that, plus 0.085Y, which is the interest from 8.5%. We want it to equal $2,000. And next we want to solve. This is the part B. What amount should we invest in each fund? Right. So we're going to solve for X. X equals 25,000 minus Y, and then we're going to plug it in. 0.06 times 25,000 minus Y plus 0.085Y equals 2,000. The 0.06 is going to go into each piece, and we're going to get 0.06 times 25,000 turns into 1,500 minus 0.06Y plus 8,500 thousandths Y equals 2,000. So we can simplify here, and we can subtract 1,500 from both sides, giving us 0.025Y equals 500, and we get Y equals 20,000 at 8.5%. So plugging it back in, 25,000 minus 20, we're going to get 5,000 for X. So 20,000 at 8.5%, 5,000 at 6%. The homework assignment is on Moodle, so you can look at that. Otherwise, here it is. Reminder to do all algebraically. So don't just plug them in on your calculator.